Sorry, the last video we had some technical problem and we were disconnected. So let's continue with the review for exam 1 with question number 17. The following data were obtained in a kinetic study of the hypothetical reaction A plus B plus C gives the products. So it's asking for the reaction rate with respect to C. Let's write the rate law. It's K, A to the power of M, B to the power of N. Let me write it here since here we don't have space. So rate is A to M, B to N, and let's call the exponent for C L. So we are solving for L, but before finding L, we need to find M and N. If you pay attention to the data table, there is no possibility that you will find both A and B, any two sets of reactions, that you find A and B concentration constant, so you can find L straight away. So you need to find M and N first. If you compare the rate of experiment 4 to 3, it would be, I just write the final equation, 0.2, 0.6 for N, for N, and for L, or let's say for B and C, you have these. So you can cancel them, and then 1/3 is 1/3 to the power of M. So M is going to be 1. In order to find N, let's find the two sets of experiments where A and C are constant. So it takes us to comparison between rate of 5/2. So it would be 20/80 the rate, and the ratio of concentrations same. The only thing that should change is B, which we have it here, and for C we have this that you can cancel. So 1/4 is 1/2 to the N, means N is 2. Now you can work with any of them for finding L. Compare any of the two, because now you have M and you can plug them in. So it would be 80/160. For concentrations of A, you have 0.2/0.4. You found M as 1. Plug it in. For concentrations of B, you have both 0.4 and 0.4, and N is 2, but anyway, it's 1. And for C, you have 0.4/0.2 to the power of L. Then you will see that 1/2 is 1/2 for A, and you have 2 to L. So here and here. So 2 to L is 1. Which exponent takes every number to 1? 0. So it's 0th order towards C. So if you want to substitute these M, N, and L values, M was 1, N was 2, and C does not exist in the rate law because L was 0. Any number to the power of 0 is 1. Okay, that was a long question, huh? Let's move towards question number 18. Another rate question. The rate constant for a first order reaction is 1.5 times 10 to negative 2 per second at 710 Kelvin, and this is K1 and T1 is 700 Kelvin, and K2 is 4.1 times 10 to negative 2 per second at second temperature 884 Kelvin. It should remind us of Arrhenius equation, ln K2 over K1. What are we trying to find? The activation energy, and R is given. EA R 1 over T1 minus 1 over T2. So plug them in. 4.1 times 10 to negative 2 per second divided by 1.5 times 10 to negative 2 per second. And it's going to be EA. R is 8.35 joule per mole Kelvin. And inside parentheses that you need to calculate is 1 over 710 minus 1 over 800. Make sure you put them in separate parentheses in the calculator. So on the right side, the ln of this ratio is going to be 1.004 equal to EA over 8.31. If your calculation is correct, the subtraction of these two fractions is going to give you 0.00028. Then EA is 2.98 times 10 to 4 joules, which is about 30 kilojoules per mole. I just changed my joule to kilojoule, multiplied it by 1,000. Okay, question number 19. Question number 19 is asking for the equations are given. The decomposition of ozone may occur through the two-step mechanism shown below. The oxygen atom, this, is considered to be what? Activated complex, a catalyst, reaction intermediate, or the product. So you see that it's been created in one step and it's been consumed in the next step. So that matches the definition of reaction intermediate. C is the correct answer. Question number 20. It's giving you 3 equations. It's asking for the rate law. You know that the rate law is written based on the slow step, because that's the slow step that controls the rate of the entire reaction, slow step. So N2O5 is a slow step, the composition of N2O5 to NO2 and NO3. That's the slow step, right? So go ahead and rate law based on the only reactant you have here, N2O5. Okay? Questions number 21 and 22 are about integrated rate laws. The equations are given in the exam. So it's a second order reaction. So let's just write down the second order reaction, integrated law for second order reaction first, and then see what's going on. A second order reaction starts with an initial concentration of 0.1 mole per liter. 0.1 mole per liter of the reactant. If the rate constant is 2.4 times 10 to negative 2 liter per mole second, what is the time? We're solving for time required to decrease the initial concentration to 0.050 mole per liter. So the key to solve this problem is to organize your data to know which one is A0, which one is AT. And you just plug them in. That's all you basically need to do. Equal to minus 2.4 times 10 to negative 2 liter per mole second, moles per liter, and times T plus 1 over 0.100. So you have on the right and left side you have 20. On the other side you have 2.4 times 10 to negative 2, and here you have 10, and T, then it would be, I found 460 seconds. And finally, the last question on this is review. Is about a first order reaction. At a given temperature, a first order reaction has a rate constant of, let's write the equation. Rate constant is 2.5 times 10 to negative 3 per second. How long will it take? We're solving for time again. For the reaction to be 35% complete. So, means that we need to solve it based on this equation, but seems like we don't have AT and A0. But yes, you do. From this data, 35% complete means how much is left? 35 out of 100 is complete. So 100 minus 35, 65% remained, right? 65% of A0 is remained. So can I say AT is 0.65. 65% is 65 divided by 100. 65 over 100 of A0 left. Correct? Because AT is what is left from the initial concentration. If 35% is complete, means 65% is not complete. 65% is 65 over 100. So go ahead now, go ahead and plug it in. The ln of 0.65 A0 over A0 is equal to K is minus 2.5 times 10 to negative 3 per second times T. So cancel A0 and A0. That ln will be, I don't have the breakdown, but I know that T, I found it as 172 seconds. So you just find the ln of 0.65 divided by 2.5 times 10 to negative 3. I hope this review was useful for you. Don't forget to ask me if you have any further questions. Good luck.